All right, so if you have your packet, this does not have page numbers, so it makes it a little tricky if you're trying to find stuff. So please find section 3.34, constructing truth tables at the top. So make sure you're on the correct page. What also will help you is if you have your yellow sheet with all the truth tables available, because we're going to do a bunch of truth tables as we keep going through the notes. So this is a little of bit of a review because we've done this before. So when you're constructing truth table, you're assigning a letter to each simple statement. Those are the P, Q, and R. There are actually bigger truth tables with more letters, but the biggest one we're going to do is with 3. You're supposed to count how many letters you assigned to N. So let's say there were 2 letters, which you guys are used to by now. If there's 2 letters, it's 2 to the N rows. So 2 to the second power is 4. So that's why if you only have P and Q, we've been making a table with 4 rows. What if you have 3 letters? What's 2 to the third power? 2 to the third power is 2 times 2 times 2, which is 8. So that's why for the PQR table, we need 8 rows. So over here, construct the truth tables. We've done this before. This statement contains 2 letters, so we need 4 rows. And we're not going to do this because this is actually a simple one, but let's just fill in the top. You would need PQ. What would be the next row that I need? Column. What's the next piece of this table going to be based on this? Negating P, right? So it's not P, and then you have not P or Q. And I'm not going to make you do this because we've done way more complicated ones. Over here, this next one, it has 2 letters, so we need 4 rows. Again, I'm going to need P and Q. But in this case, what's, hi? It is Adriana here, she's not here. Thanks. So since we have parentheses, because this is what sometimes tricks people, over here I only needed not P. But before I negate this, I actually need P and Q. So you would do that first, and then you would do P and Q negation. We're not going to fill in the whole thing because you guys have done this before. And finally for C, you look, and 1, 2, 3 letters. So it's 2 to the third power, so we need 8 rows. So let's fill this in because we actually don't have P, Q, and R in all of our notes packet. P, Q, and R. And then remember the first part for P, the first column goes in 4s. So you would have true, 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 and true. And then it would be false, 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 and false. So if you just happen to remember the first column goes in 4s. For Q, does anyone remember? Pairs. So we're going to start with true, true, false, false, true, true, false, false. So this one goes in 2s. And the last one alternates. It's true, false, all the way to the bottom. We're not going to fill in this whole thing, but let's just do the top row. Like, how would you split this up? So first thing I notice, I have parentheses for this end statement here, and I have a negation for both P and Q. So I'm going to do not P in this one. Then I would do not Q. Then I would do not P and not Q all together. And the last one is the or. R or not P and not Q. Are there any questions? Okay. For the next part of the notes, we're going to go skip 2 pages. So we're not going to do anything on the next page. We're skipping all of that. We kind of did this. We did the conditional, we did the biconditional. Just a quick reminder for the conditional, when is this one false? Remember the broken promise? If you all get A's on the test, then I will bring you donuts. You all got A's, but I didn't bring you donuts. So you should not be happy with me, so that's why it's false. That's the only way that a conditional is false. And for a biconditional, if they have the same truth value, it's true, or if they have different truth values, it's false. So we already did that. I'm going to go to the next page. So find the one where it says section 3.4. Okay? We're going to talk about something that's called a tautology and self-contradiction. So two new terms. And this actually was on your quiz. And I don't know if you remember, but I gave you that definition because we haven't gone over these notes. Something that's called a tautology. It's a compound statement that is always true. A self-contradiction is a compound statement that is always false. And when I say always true, that means the last column in the truth table, all of it would be true or all of it would be false. So, for this example, it's actually missing some brackets. Okay, determine if each statement in this compound statement is a tautology, a self-contradiction, or neither. So what's missing is the following. You would put the second part in brackets like this. I want you to add those to your notes because we've got like two if-then statements. So this comes second. And then over here, I want you to put the first part in parentheses. So it's Q and not Q in parentheses. This whole thing in brackets. Okay? So we're going to make a truth table for this. And over here is Michelle here and Jacob. Michelle's no longer. And then Jacob is not here. Thanks. So to do so, we need to make a truth table. And look at the last column. Okay? So the last one, if it's all true, will be tautology. If the last column is all true, we have a tautology. If the last column is all false, then we have a self-contradiction. If the last column is a mixture, T and F, which is a lot of the truth tables we've had, then it's neither. So it's still a valid truth table, it just doesn't have a name. Okay? So in this, how many letters do we have? How many different letters do we have? It's 2 because it's just P and Q. So we need 4 rows for this. I'm going to split this and do P and Q. This goes true, 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 false, false, true, false, false. So we haven't done many truth tables with brackets. Whenever you have brackets and parentheses, the same rule applies as if you did, do you remember, please excuse my dear Aunt Sally, like parentheses, exponent, multiply, divide, add, and subtract. So in this, what's the first thing we got to do? The parentheses. Okay, so you would work within the bracket, do the parentheses first, then do the bracket, and then do the whole thing. And within the parentheses, I have Q and not Q. So the first piece that I need is not Q. So that's my first, or actually both, not Q and then not P. So it really doesn't matter. But I'm just going to go not P, not Q. Let's have you guys fill that in. All right, let's check. I've got false, false, true, true, false, true, false, true. Okay? The next thing that we're going to do is the actual parentheses. So it's Q and not, and not Q. So I'm looking at Q, which is right here, and not Q. So if it's true and false, it's false. If it's false and true, it's false. If it's true and false, it's false. And if it's false and true, it's false. The next thing I'm going to do is this if and then statement inside the bracket. So try to fit this whole thing in. Q and not Q, sometimes it's tricky, then arrow, not P. So if Q and not Q, then not P. So I'm going to be looking at this column right here. So if this happens, and then I'm going to look at P, which is not P right here. So let me remind you, for if and then statement, when is it false? When it's true, false. If the second piece is false, that's when it's false. So it's very important that you actually go in this direction, that you actually follow. If false, then false. What is that? True. Okay. If false and then false, it's also true. What if we have if false, then true? Because we're going from this to this, from this to this. If false, then true. Check your yellow sheet. It's true. And last one, if false, then true, is also true. All right, we're ready for the last piece, which is if P, then, and you got to write this whole thing. Include the brackets. So now we're going to look at P, which is the first column right here. If P, then all of this that I wrote in red right here. So again, it's the if and then statement. If true, then true. It's true. If true, then true, we get. If false, then true. It's also true. If false, then true. It's also true. All right, all this work after you do a truth table, and it comes out all to be true, since the last column is all T's, or truths. The given compound statement is always true. Always true. Every single case that we have is true. So this is a tautology, okay? And we can cross off the other ones. We're not going to go through B because this one comes out to be self-contradiction, because it comes out to be the same thing. If all of it is false, then we would have in the last column, then it would be a contradiction. Are we okay with this? I'll do one more page of notes. So please skip the next one. Actually, wait. And go to the page where it says 3.51, equivalent statements. I'll do 2 examples about that, okay? Many times in an argument, there's more than one way of saying the same thing. An argument, I don't mean like a fight with someone, argument like in logic, okay? In this section, we are going to look at how you can prove or disprove that 2 statements are equivalent. An equivalent means they mean the same thing. So, an equivalent compound statement is a compound statement that are made up of simple statements. And when we say simple statements, those are your P's, your Q's, your R's. And they have the same truth value for all possible truth assignments. So it's either all, identical, or it's not going to work. It's not equivalent. So what do I mean by that? Here's an example. I got an A in math, or I got an A in English. Okay? And here's if I didn't get an A in math, then I got an A in English. Does this mean the same thing? Let's see. Because it's like, okay, I got an A in math, or I got an A in English. If one of them is true, then the whole thing is true. Over here, if I didn't get an A in math, then what has to be implied? Where did you get your A? You got your A in English. So before we can do this, let's write them in symbolic form. So for the first one, this is P, this is Q, and how would we write this in symbolic statement? So for this one, it's P or Q. And then this one, if I didn't get an A, then I got an A in English. That's the if then. But what happened with the first part? It's gotten a negation, right? So it's going to be not P, then Q. Now, what symbol are we going to put in between? Because I want to show that this is equivalent. And actually, I should write that here for the notation. The triple kind of like equal sign, that means equivalent. It means equal, but we can only say equal about numbers. For statements, we say that they are equivalent. So what you're going to see in logic, you're going to have this, not really an equal sign, but you would say is equivalent to. So to show that they're equivalent, we need to make a truth table for both of them. So the first one, let's do P, Q, P, or Q. Why don't you guys fill that in using your... My bad. Ricky, you win. This is or. I owe you a Twix. If you catch my mistake, I give you candy. I don't have any, but you remind me. I'm going to go buy some Twix. Very good, very good. Oh my gosh. Yes. So now let's fill that in using our yellow sheet. True, 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 false, false, true, false, false. So for the or, true or true? True, true, false? True, false or true? False or false? False. Okay. Now let's do this one. So again, I'm going to split this P and Q. What I also need in this one is the not P, and then not P. If not P, then Q. Why don't you guys take a second to fill that one in? So for the last one, if I have if false, then true, that's true. If false, then true is also true. I'm sorry, I'm looking at this one. And then if true, then true. And then if true, then false, it's false. Okay? So what you're really comparing to see if they're equivalent is the last column. Do they have the same truth values for each row? Yes. So since the last column of the truth table above are, crossing this off, identical, the two statements, P or Q, and if not P, then Q, are, I would cross this off, equivalent. We would write it like this. P or Q is equivalent, using the special symbol, to if not P, then Q. Can you handle one more? Last one. I just have to get this one in and we're done. I can't, but we're going to do it. Consider the following statements. I got an A. Next one. It is not true that I did not get an A. So for this one, how would we write it in symbolic form? I got an A. P. That's it. P happened. Next one. It is not true. What has to happen if you say something like this? It is not true. It is false. It is not the case. You need parentheses. So it is not true. That's negation. And what happened? That I did not get an A. It's not P. So it's actually like a double negation, which kind of makes sense. If P happened, it is not true, not P, I got an A. It is not true that I did not get an A. Those mean exactly the same thing, even though in everyday language that we probably would never say that. So how do you make a truth table for this? Well, the truth table for P is simply this. P, what are the two cases for P? True, false. Done. Now for this one, we start with P. then we're going to do not P, then we're going to negate not P and see what happens. So P is true, false. Not P is false, true. And then false changes to true, true changes to false. And then you're looking at, all right, does the last column or the only column, do they look the same? Are they identical? They are. So these are equivalent statements. So since the last column of the truth table above are identical, the statements P and it is not true that not P are